So, hey guys, we are the group number 4 presenting our logistics center database project, Practical One. My name is Delvin, and with me are Ajmal and Sinan. Our project is about designing and implementing a logistics center database that manages, manufactures, items, shops, personnel, and delivery orders. The main goal was to show how object relational features like object types, inheritance, REF, DERF, links, and nested tables that work together in a real system. We worked on this project for about 1 week, meeting daily on Zoom and at university to plan, code, and test everything. Then now we will each explain our part.
Hi, I'm Ajmal, and for our logistics system, I led the class diagram in the draw.io. I started by locking the core entities, which are manufacturer, item, and shop, then modeled with the item with inheritance, which is perishable item, electronic items, and industrial item. To make behavior more explicit before any SQL, we added methods, a base, which is get description, that each subtype overrides and is expired for perishables, and a comparator on deliveries. And relationships and multiplicities are clear, like items come from one manufacturer, and an item can live in many warehouse locations. And the delivery orders ties shops, planners, and items together with the required foreign keys. And once the diagram was solid, like writing the tables, keys, and the queries become mostly mechanical. Yep, thank you.
Hi, my name is Muhammad Sinan. I am the one who created the AR diagram for our project. I turned our class diagram into our AR diagram and it matches Oracle code we wrote. The main table is item. Think of it like a list of product we store. Some items are perishable like milk, some are electronic like laptop, mobile phone, TV, and some are industrial like engine parts, automobiles. We keep them together in the same table, and the type decided what extra field they have, like expiry date for perishable or validity for electronic. Each item has a link to its manufacturers. In Oracle, that link is reference. You can think of it like pointer to the row in the manufacturers. In the code, we use reference to store the link and dereference to read the manufacturer's name. Item can sit more than one storage place in the warehouse, like as a shelf or bin. We model that as a nested table called storage location. In queries, we open it with the table to list all the slot for each item. On the people side, we have personal tables. One person can have planner data, mechanic data, or both. That's why the table has two object columns, like a planner and the mechanic data. In code, we need role specific field like it's a planner and other thing. We use tree to read them safely. And so finally, when you come to deliver orders connect everything. It's linked to shop and an item and the planner who arranged the delivery. Those are also ref links to our core. You can show friendly name with the D reference, like the shop name, item name, and the planner's full name. So when it comes to big picture, it's very simple. Like items, what we store, and the manufacturers who supplies it, a storage location where it is sits, personals who work here, and the delivery orders, which shop ordered what and who planned it. So this AI diagram is a one-to-one blueprint for our code. What you see in this box is exactly what we have created and tested in Oracle.
Hi, I'm Delvin again, and I worked on the live SQL implementation. Using both diagrams, I created all the object types, subtypes, and tables. In the script, we inserted real data for manufacturers, items, shops, and personnel. We used REFs to connect them and DERF in our queries to show readable names. We also use the treat and isOf type to access subtype attributes. Each type has its own methods. For instance, like show prints delivery details, add order inserts new order and calculates the commission and the calculates storage cost, gives the storage cost over days. For perishable items, we added is expired to check the expiry dates. We tested everything using small PL/SQL blocks and DBMS output, making sure every part worked perfectly. It was challenging at first, but seeing the full system run smoothly was a great feeling as well as a great relief. To conclude, in a nutshell, this project helped us understand how the object relational database work in real life, not just in theory. We also improved our teamwork, communication, and problem-solving skills while working on it. Honestly, it didn't feel like a simple practical assignment. It felt like building a real project, and we are really proud of how it turned out. Thank you and have a nice day.